All right, so let's take a look and see how we can prove what certain angles are based on other angles. And we're going to do that using a couple different diagrams here. And so we're going to first take a look at vertically opposite angles. Okay, and if we want to, so we're going to take a look at how these are the same. Now we have two straight lines here. Okay, and we have four angles that are formed by these two lines. We have P, Q, S, and R, or P, Q, R, and S. Now, what we can kind of know for sure is that if we have a straight line, the two angles that make up that on that straight line are equal to 180 degrees. So we know that P plus Q has to be equal to 180 degrees. And this is supplementary angles. And I'm just going to do a little bit of shorthanding here, just don't want to write out the whole thing. Okay, so we know that P and Q have to equal 180 degrees. We also know that, again, S and R, by the same property, have to equal to 180 degrees. Okay, so these are supplementary angles. Now, we know that because of this straight line. We're kind of starting with the horizontal line, but we also have this diagonal straight line as well. And so based on that, we know that S and P have to equal to 180 degrees. And again, this is by the same property, supplementary angles. And we know that R and Q have to equal to 180 degrees by the same property. Now, if we look at all of these proofs that we have here, that we know, okay, these are all based on supplementary angles. If P plus Q equals 180 and R plus Q equals 180, Q is exactly the same. That means that P has to equal R, okay? So that's based on these two right here. Okay, based on the fact that P plus Q equals 180 and R plus Q equals 180, the P and the R are in the same spot. They have to be the same size. Okay, otherwise that doesn't work. Okay, in the same way, we can look at, let's go here, S plus R equals 180 and R plus Q equals 180. Okay, the R has to be the same, so that means that the S has to equal the Q. Okay, so P and R, these ones have to be the same angle, and S and Q, those ones must be the same angle. They must be equal. And we use the term vertically opposite angles are congruent, or VOAC, and we're going to kind of use that in some of our proofs as we move along, or we can use that just like we use supplementary angles as part of our proof there. Now, interior angles, okay, so we're going to move on to the next one. We're going to do a few of these here in a row. Okay, interior angles are angles which are inside two parallel lines. Okay, so we have these two parallel lines, and C, D, E, and F are four interior angles. Now you'll notice I'm using the same lines here and the same letters, so you can kind of correspond it to that. Now, based on what we see here, we could use some kind of stuff from, this is a little bit different here. But what we're going to use is we're going to use, again, our idea of supplementary angles to prove that C and F are the same and D and E are the same. So inside of a set of parallel lines here, okay, so right here, if we have two parallel lines and a transversal, C plus E is going to add up to 180 degrees. Okay, sorry, I should put that over here. C plus E is equal to 180 degrees, and that is based on interior angles. Okay, so if we have common interior angles here, these two have to add up to 180 degrees. Now that's, again, based on a transversal going through two parallel lines. Okay, we also know that D plus F, based on the same property, has to equal to, these are also interior angles, they also have to equal to 180 degrees. Well, the fact is that C plus D equals 180, and this is supplementary angles. Okay, C plus D equals 180. And so because of that, okay, C and E is 180, and if C and D has to be 180, that means that E and D have to be equal. So E has to equal D based on our proof that we just did there. So E and D are the same. Okay, these are alternate interior angles. They're not together here. Okay, they're alternate interior angles. Those have to be the same. And by the same proof, we can also do C is equal to F. Okay, so C and F are equal, and I'm just going to kind of draw little circles around those again. Okay, C and F are equal, and E and D are equal as well. Okay, based on this proof here, okay, looking at the interior angles and then the supplementary angles, we can prove that that is in fact true. And we can use this as a proof here. Interior alternate angles are congruent, or IAAC. Okay, our interior alternate angles are congruent, or that means that they are the same. Now we can do the same thing with exterior angles. Okay, and it's using very much the same proof. Okay, so in this case here, we can take a look again, and we can use our interior angles if we wanted to as well. But based on what we know here, and instead of going through the entire proof on this one here, we're going to say that A has to equal H, and B has to equal G. Okay, B and G, these ones are the same, and A and H are the same. Okay, it's not AH glass, it's just the fact that they're the same here. So AH are the same and BG are the same. Okay, so those are common, and that is because exterior alternate angles are congruent as well, and that goes on the same proof that we came up with on interior angles, except now we're just looking at exterior angles in the same way.